what we are going to be learning in 10.5 is how to solve logarithmic equations. So you know it's an equation when you have an equal sign. Self-explanatory. So the way this is going to turn out is we want to get x by itself, right? The only problem is it's in the middle of this mess. But we learned in Unit 1, not Unit 1, in Lesson 1 of Chapter 10, this whole wheel method that I was explaining. So let's go ahead and do that. Let's just try to see something. Let's change this logarithmic into an exponential. So 2, right? So 7 squared is equal to x. Well, I know what 7 squared is. I know 7 squared is equal to 49. So I can go ahead and say x is 49. I'd love to lie to you and be like, they're all going to be this simple, but they're not. So let's take a look. Oh, well, hopefully there's no questions with how this turned out. When your x is not your base and not what it's equal to, it's going to turn out to be really easy. But let's take a look at one that is our base. Hey, my x is over here. So when I go ahead and do this one, I'm going to do it in a different color so we don't get confused. Right? Go ahead and do my wheel, turning it from log to exponential. X to 3 over 2, all right, is equal to 27. This is looking weird. This is looking weird because, all right, now I gotta get x by itself. Easiest way, when we have an actual number here, like, okay, this is a real number, but we have like maybe 7 right here, it's gonna be easier, but let's just take a look. I wanna cancel this 3 over 2. How do I cancel it? I multiply it to that power, to its opposite power, right? So my opposite would be 3 over 2. It's reciprocal. So if we had 7, like I mentioned previously, its reciprocal would be 1 over 7. What I do to one side, I do to the other, right? So what ends up happening is these cancel, and I am left with x is equal to 27 to the 2 over 3 power. Now I encourage you to go ahead and put this in the calculator unless you want to do the work for it. So this would be the cube root of 27 squared. Now I am so brilliant that I know this answer by heart, and this is x equals 9, right? 27 squared. It's so easy that I don't have to do it, right? So yes, go ahead and plug it in and you will see, hey, x is equal to 9. Not that bad. Not that bad. Take a look at the next one. This one's a little strange, right? Because we're like, all right, there's a 0. Zeros freak you out a little bit. So let's go ahead and do this in green. So x to the 0 power is equal to 2. X to the 0 is equal. Oh wait, I wrote that wrong. Oh no. Right. X to the 0 is equal to 2. Well, this one's a little weird because I know I can't cancel it out with anything. The reciprocal is 0, 0. All right. But we have to think a little bit further into this one. We have to say, hey, anything to the 0 power is not going to be 2. I know that for a fact. And if we were to, kind of draw, a logarithmic function, we have an asymptote right here at x equals 0 anyways. So I know it's never going to be this point right here. So that is clue 1. It is never going to happen. Anything to the 0 power is 1. It's 1, right? Even right here, when we have 1, our x value, it's 0. It crosses at 0. So this, we're going to go ahead and just say, hey, this is not true. You can write NA, but I like writing not true because I like telling math you're wrong, right? And so this one is a little different. I wanted you guys to see this one is never ever going to happen like this. So let's go ahead and try number 4. See, hey, let's go ahead and do this wheel situation. Log to exponential, 2 to the x is equal to 64. This is going back to previous unit where I'm like, all right, exponentials, I need to rewrite this. I need to write this with a base of 2, right? So, all right, 2, 4, 8, 16, 32, 64. That is 6. 2 to the 6th power. Hey, they have the same bases. I'm going to go ahead and just look at my exponents. Bam. It tells me already x is equal to 6. Let's go ahead and only do number 5. We'll talk about all these other ones later in our lives. And if not, that's pre-AP material. We'll talk about it later in our lives. So, last one. This is going to be the most complicated one we see. I want to go ahead and solve for x. Let's change this to exponential. Save ourselves, right? So 2 to the 4th power, is x minus 9. Well, I know 2 to the 4th is going to be a number, right? All right. Again, the goal is to get x by itself. I know how to do that. That's plus 9 on both sides. So I tell myself, hey, x is equal to 2 to the 4th plus 9. Well, 2 to the 4th. 2, 4, 8, 16. X is equal to 16 plus 9. And I don't know about you, but I'm pretty sure I know that you know how to add. So x is equal to 25. Not that bad. So when we are solving for logs, we're going to see a couple ways we can do it. When our x is our variable big, our big variable right here. When our x is our base. When our x is our other side of the equation. And we're also going to see, hey, there's more than anything into this variable. We can add stuff in there and we can solve for x a little more complicated. So this is how we solve logarithm equations.